Now, the fourth stage is about the differences between physical and chemical change. Let's see how they're different and let's see why this is important. First, let's talk about the essentials of physical change.
Hi, my name is Ashley, and today I'm going to be explaining about physical changes. Physical changes is when a substance is not altered, the arrangement of its atoms, but it's just combined or altered physically, like in appearance. But you can always turn it back if you want. So it's just changed physically, not like chemically altered. So I'm going to be showing two examples about it, and the first example involves using water and salt. Now, during our stage 3 video, we also talked about using water and salt, and we did. And we did that to describe solubility of some things, like salt is soluble, and today I'm going to be using the solubility of salt, like dissolving in water, to show you how it's a physical change, not a chemical one. Okay, so there's clear water, as you can see, and there's white salt in a container, and I'm gonna be putting some amounts of salt in water, and in a few minutes or so, it's gonna all dissolve in, and it's gonna be salt water. And you will think it's going to be different from salt water. Salt water is going to be different from salt and water, but actually the substance hasn't changed. They're just combining, and even if it dissolves, it's still two separate substances. This is not one. Like, they didn't combine actually, they just dissolved in it. So water, as you can see, there's salt in it. So now it has become salt water, as you can see. However, if you let the water evaporate for a few days or hours, the salt is going to be left there, and the water is going to be in the air because it is in a form of gas now. So that means that H2O is still H2O, but in a different form, and salt is still salt. So that explains how this change is a physical change, not a chemical change, because if it was a chemical change, we wouldn't be able to change it back to its original substances. Okay, thank you. Hello, my name is Ashley, and we're going to be talking about the second example of physical change. Physical change is when a substance is altered physically on the outside, like, but not on the inside, so the arrangement of atoms hasn't changed. For example, a chemical change would be you eating like a radish and you digesting it out, and what's coming on the other end has chemical change because it is chemically changed. But if you like turn like a piece of glass like this into like a colorful glass or like a different shape, it's gonna be only physical change, because even if it looks really like different, it's still gonna be glass. So yeah, today I'm gonna be showing you a physical change with this radish, and this looks like this right now. It's a piece of radish, but if I chop it off, it's gonna look definitely different, but it's still gonna be radish. It's still gonna be nothing else. So yeah. So I'm chopping it off right now. So now it's chopped off like this, and even if it looks a lot different from this, which it looked like before, it's still radish and it didn't change physically at all. So this is a physical change. Yay! Hello, I'm Ashley, and I'm going to show you a third example of a physical change. So this physical change example includes using clay and its malleability. So this is clay, and today we're going to show you how this clay can physically change. So This clay looks like this right now, but if you pound it, it definitely looks different from the original version. And even if it looks drastically different, it's going to be still the same clay. So that kind of explains how physical change goes like. Also, if you mix one clay with another one, if you mix the black clay with some of like the brown clay, you're gonna think since the black clay and the brown clay is mixed together, it's gonna form a new clay. But it's only like black clay and brown clay mixed together and still separate. It's black clay and brown clay. Nothing has changed. Nothing has like created a new substance. So this is still a physical change. It just looks and the color is different, but the substance didn't really change. I'm saying that the arrangements of black clay and the arrangements of brown clay did not change because I mixed it. So this is a physical change.
Now, let's take a look at the chemical changes.
Hi, this is a candle. First, a candle is made up of wax, which consists of carbon and hydrogen. When you burn the wick of the candle, it produces liquid wax, and it evaporates. This evaporation of the wax creates a gas that chemically reacts with the oxygen in the air, producing this fire on the candle. And this process shows the chemical change of the wax in the candle. Out of the many chemical changes, one of the common ones is flammability. And today we will test this flammability of a paper by burning it with this lighter. The fire is added onto the paper and it starts to burn rapidly, which tells us that the paper is flammable. After every part of the paper is burned, it changes into ashes. These ashes are a totally different substance from the paper. This happens because burning of the paper is a chemical change, and the chemical changes form entirely new substances, like the ash.
Now, because we looked at physical and chemical changes, let's see how they actually differ, and let's see how their unique properties are different from each other.
Hi, this is Ashley. I'm going to explain, describe, and compare the physical and chemical changes. First of all, let's describe physical change. Physical change is a change of matter from one substance to another. During a physical change, the physical property may change, but the chemical property never changes, so there's no new arrangement of atoms in the physical change. In addition, physical properties can be clues that physical change is happening. Change of physical properties. Next is the chemical change, which occurs when one or more substances change into entirely new substances. After a substance goes through a chemical change, its properties are different, and chemical change is also commonly known as chemical reaction. Some of these chemical changes are large and explosive, but others are unnoticeable. To explain farther, in a chemical change, atoms rearrange to form new substances. One example that shows both physical and chemical changes are preparing a meal. Chopping vegetables, for instance, change the look of the shape of the vegetables, but it does not change the vegetable itself. So this is a physical change. However, if you cook the vegetables, it burns with fire and grease, and it forms a new substance, which are the cooked vegetables. That has new substances, of course, an arrangement of atoms. This is a chemical change. Another example is welding. Cutting off the metals with toes do not change the arrangement of atoms of the metal. This is a physical change. However, using heat to melt and combine the metals change the metals itself. This is a chemical change. A lot of activities use both physical and chemical changes to accomplish.
And this was our fourth stage of our atom project. Thank you. This was all about atoms and the changes it might take, and also about the properties, which included physical and chemical properties. We hope that you learned a lot through this video. Thank you.